Imagine a star, not our calm sun but a cosmic rebel, burning so hot and bright it lives on the edge of destruction. This is a Wolf-Rayet star, rare, massive, and spectacular. For every billion stars in the Milky Way, only a handful are Wolf-Rayets. These are the final, fleeting stages of the universe's most massive stars, born with dozens of times the sun's mass. You'll find them in chaotic stellar nurseries, like the Tarantula Nebula, where stars are born in cosmic cities of gas and dust. Wolf-Rayets are the evolved descendants of the biggest, brightest stars, now shedding their outer layers in a brilliant finale. Unlike our sun, which fuses hydrogen, Wolf-Rayet stars have moved on to fusing heavier elements, helium, carbon, oxygen, releasing immense energy. Their surface temperatures can soar over 200,000 degrees Celsius, more than 30 times hotter than the sun. This heat drives their wild, unique behavior. The name comes from French astronomers Charles Wolf and Georges Rayet, who discovered them in 1867 by spotting stars with strange, bright emission lines. Most stars show dark absorption lines, but Wolf-Rayets broadcast their chemical makeup in wide, colorful bands. This revealed that these stars are violently blowing their own material into space. Their discovery opened a new chapter in our understanding of how massive stars live and die. Wolf-Rayet stars are nature's most extreme possibilities, cosmic diamonds in a vast desert. Picture approaching a Wolf-Rayet star aboard our ship of the imagination. The first thing you'd notice is the overwhelming glare, thousands of times brighter than our sun. Most of this light is high-energy ultraviolet, powerful enough to tear molecules apart. This isn't life-giving light, it's a sterilizing, destructive force. Next comes the wind, no gentle breeze but the most powerful stellar winds in the universe. Imagine the sun's solar wind, then multiply its power by 1 billion. Wolf-Rayet stars blast their own substance into space at over 2,000 kilometers per second. The wind is a hurricane of the star's own atmosphere, dense and furious, shedding the mass of an Earth every year. This material forms a glowing, turbulent cocoon, an eerie, deadly nebula energized by ultraviolet radiation. The radiation pressure is immense, like standing before a fire hose of light. It's this pressure that drives the star's outer layers away, fueling the powerful winds. For any traveler, getting closer means fighting against a relentless, overwhelming force. The star is actively pushing the universe away. Approaching a Wolf-Rayet is a journey into a cosmic tempest. It's beautiful but utterly deadly. What happens if you reach the star itself? Here, our usual ideas about stars break down. Wolf-Rayet stars don't have a clear surface, just a chaotic, blurry transition where the star's edge dissolves into violent wind. There's no boundary, only a region where the wind becomes impossibly dense and hot. The star is hidden within its own hurricane. The atmosphere and surface are one, a storm of energy. Even millions of kilometers away, temperatures are thousands of degrees. Cross the threshold, and temperatures skyrocket to hundreds of thousands of degrees Celsius. At these extremes, matter as we know it can't exist. Atoms are ripped apart instantly. You wouldn't melt or burn, you'd be vaporized into plasma in a fraction of a second. This is a maelstrom of physics. Extreme heat, crushing pressure, and relentless radiation. Atoms are stripped of electrons, becoming part of the star's ionized gas. You'd cease to be a distinct object, absorbed into the star's violent outer layers. There's no impact, just instant assimilation into the cosmic furnace. The storm is the star, and you become part of it. Let's follow what happens to your atoms after you're vaporized at the edge. Swept into the star's powerful currents, your atoms descend into the interior. First, they pass through the outer envelope, where helium fuses into carbon and oxygen, fueling the star's energy and winds. Pressure and temperature climb to unimaginable levels, hundreds of millions of degrees, densities far beyond anything on Earth. Here, atomic nuclei are forced together. Your carbon and oxygen atoms become fuel, fusing into heavier elements like neon and magnesium. Deeper still, silicon fuses into iron, the final stage of a massive star's life. Iron is cosmic ash. Fusing it consumes energy, sealing the star's fate. Your atoms become trapped in the core, a place of crushing gravity and pressure. Eventually the core collapses, triggering a titanic supernova explosion. The atoms that were once you are blasted back into the cosmos at nearly the speed of light. In a Wolf-Rayet star, your journey ends in a spectacular cosmic firework. You become part of the universe's next generation of stars and planets. The cycle of cosmic recycling continues. How does falling into a Wolf-Rayet compare to falling into our sun? The sun is a calm, middle-aged star. A Wolf-Rayet is a hyperactive giant. Approaching the sun, you'd face intense heat and light, but its solar wind is a gentle breeze compared to a Wolf-Rayet's hurricane. The sun's visible surface, the photosphere, is about 5,500 degrees Celsius, orders of magnitude cooler than a Wolf-Rayet. Falling into the sun, you'd be vaporized, but the process is less instantaneous. You hit a defined gaseous surface. In a Wolf-Rayet, there's no clear impact, just a sudden total dissolution. Inside, the sun fuses hydrogen into helium, a stable, long-lasting phase. Wolf-Rayet stars have exhausted their hydrogen and burn heavier elements in a desperate race against gravity. The Wolf-Rayet phase lasts only a few 100,000 years, a cosmic blink. If you fell into the sun, your atoms would remain locked in a quiet stellar remnant. In a Wolf-Rayet, your atoms are destined for a supernova scattered across the galaxy. The difference is between a peaceful retirement and a spectacular cosmic finale. Let's zoom in on the diver's last moments in both stars. Near the sun's photosphere, you're vaporized and your atoms mix with the outer layers, slowly sinking toward the core over millennia. Your atomic legacy in the sun is quiet. You become part of its mass, insignificant to its fate. When the sun dies, your atoms are shed in a planetary nebula or trapped in a white dwarf. In a Wolf-Rayet, your end is far more dramatic. You're annihilated, swept into the star's violent wind and thrown directly into regions of heavy element fusion. The carbon in your cells could be fused into neon in moments. Your atoms become direct fuel for new elements. When the star explodes, you're part of the payload, blasted into space at incredible speeds. The iron from your blood, now in the star's core, is scattered across the galaxy. Your atomic journey doesn't end, it begins anew, seeding future stars and planets. In a Wolf-Rayet, you become part of the universe's ongoing story. Wolf-Rayet stars aren't just cosmic curiosities, they're essential to the universe. The Big Bang made mostly hydrogen and helium. Every other element was forged in stars. Wolf-Rayets, the most massive stars, are prolific element factories. They fuse helium into carbon, carbon into neon, oxygen into silicon, and silicon into iron, creating the raw materials for planets like Earth. Supernovae from these stars make the heaviest elements, gold, platinum, uranium, in a matter of seconds. The gold in a ring, the iron in your blood, all born in the death throes of stars like these. Wolf-Rayet stars are our cosmic ancestors, seeding the galaxy with the building blocks of life. The elements they create are the seeds for future generations of stars and planets. We are, as Carl Sagan said, made of star stuff, and Wolf-Rayets are among the most important contributors. Their legacy is written in everything we see and are. Creating heavy elements isn't enough, they must be spread across the galaxy. Wolf-Rayet stars are master gardeners, sowing these seeds through powerful winds and explosive deaths. Their winds are rich with carbon, nitrogen, and oxygen, enriching the interstellar medium. This cosmic fertilizer helps new stars and planets form with higher concentrations of heavy elements. Metal-rich gas clouds cool and collapse more easily, shaping the evolution of galaxies. Without this enrichment, solar systems like ours would be rare. The grand finale is the supernova, blasting the star's contents into space at incredible speeds. The expanding supernova remnant sweeps up and compresses interstellar gas, triggering new star formation. The death of one massive star can give birth to hundreds or thousands of new ones. Wolf-Rayet stars literally shape their galactic neighborhoods. Their explosive ends are beginnings for countless new worlds. When we look at the night sky, we see a universe shaped by stars like these. Wolf-Rayet stars are not just spectacular deaths, they're engines of cosmic creation and renewal. They turn the simple elements of the early universe into the complex chemistry needed for planets and life. Their legacy is in our planet, our bodies, and the galaxy itself. We're still learning about their powerful winds, their evolution, and their explosive ends. The James Webb Space Telescope is revealing new details, deepening the mystery. These stars remind us of the universe's diversity and dynamism. Studying them pushes the boundaries of physics and our understanding of stellar evolution. In their short, violent lives, Wolf-Rayet stars give back to the cosmos, enriching it for future generations. Their spectacular endings are also new beginnings, cosmic generosity on the grandest scale.